Here's a classic pre-calc problem where they're asking for the limit as x goes to -3 of this function right here. You'll notice that you can't just plug in -3, because if you did, you'd have 0 in the denominator, which is a no-no in algebra. So what we're going to have to do instead is little algebraic manipulations. And what we're going to do specifically is multiply the top and bottom by the greatest common denominator, which is 3 times x plus 3. If I multiply the top and bottom by that, I will get, oh my goodness, on the top I'm going to get, well, let me just rewrite the entire thing. This becomes now the limit as x goes to -3 of the numerator is going to be 3x times 3 plus x. We can just leave it like that. And the bottom, notice when you multiply this to both of these terms, you're going to end up with 3 minus x. And doing that and simplifying that allows you to magically get rid of the problem child in the denominator. So your answer is going to be 3x times 3 plus x on the top. When I distribute this negative in, I'll change colors so you can see. The 3's cancel each other out, so I just get x in the denominator. And now the x's cancel each other out. And so my expression becomes the limit as x goes to -3 of just 3 times 3 plus x. And now I can plug in the -3 because there's no more issues doing that. And when I plug in -3 now, I'm going to get 3 times 0, which equals 0. So the limit as x goes to -3 of that entire expression is going to be 0. So there's your answer. Let me show you one more thing that maybe you'll notice now that we've done that problem. And this doesn't always work out like this, but in this case you can kind of see what's going to happen. Actually, this works out a lot. If you can see right here, if you can just imagine what's going to happen as this right here, as x gets closer to -3, the value in that rectangle that I'm drawing in there is getting closer and closer to 0. And if that number is getting closer and closer to 0, that means this bottom, it's not 0, but it's getting closer and closer to 0, so it's like 0.001. This number right here is getting bigger and bigger and bigger, so that number, let me change colors here, this expression right here, I should have picked a different color, this expression right here is getting bigger and bigger and bigger and bigger. This right here isn't changing. So you've got x over a number that's getting bigger and bigger and bigger and bigger, and what's x is just -3, because that's what it's getting closer to. This value is getting closer to -3, and the denominator is getting bigger and bigger and bigger and bigger. So if you have a number, -3, over a humongous number like 1 million, or now another 10 million or 100 million, etc., as this denominator gets bigger and bigger, what's the entire fraction getting closer and closer to?
0.
0. And that's another way to understand that particular problem.